Alright, we got our Unit 3 review here over triangles, so let's go ahead and dive on into it. First of all, you need to remember that all angles in a triangle add up to 180. With right triangles specifically, since you have this right angle right here, you can say these two angles will add up to 90 since you have the other 90 right here, right? And then 90 plus 90 get you 180. So kind of a shortcut on these right triangle problems here is do 2x then plus x, your two acute angles right there, and then equal 90. And then you can say 3x equals 90, and then divide, and you can get x is 30. You can also do 2x plus x, and then plus 90 equals 180. That should still work. It's just a hair quicker to do it with the two acute angles equal to 90 right there. So you'll get x is 30. Find the value of x and then classify the triangle by its angles. So this is, of course it's a right triangle since it's got the right angles and then those are both acute. So yeah, we would say it's a right triangle. If you want to also name it by its sides here, since the two sides are different lengths, you could also call it a scalene triangle. So that'll be that right there. Now 2, you don't have that option to where you can say two angles add to a certain thing, so you're going to have to do all three angles. So 2x plus 3x and then plus 55, and then that equals 180 degrees. Okay, and then you can combine up your x's. That's 5x plus 55. I guess you could have subtracted in that same step as well. That'll be 5x, and then what is that? I think 125. And then when we divide, we should get 25 right there. Let me double check my arithmetic here. 180 minus 55. Yep, 125 divided by 5. Yep, awesome. And then this would be, looks like all sides are different again, so it'd be scalene, but then this is, based off of its angles, this is an acute triangle, and that's because every angle should be acute. If you go plug 25 back in, you can go and verify that. 2 times 25 is 50 degrees. 3 times 25 is 75 degrees. All of the angles are acute, so you wouldn't need to worry there about that. Okay, 3 has got this theorem. We'll probably use it more on the next few problems here. But the theorem is saying the exterior angle, if you took a side of a triangle and extended it, that's called an exterior angle, and the exterior angle is equal to the sum of the two remote interior angle right there. So apparently x is equal to 70 plus 50 or 120 degrees. Now, if you don't want to do that there, you can just use the fact that this is a linear pair. And then you can say, well, you can use the fact that it's a linear pair, but then go and add these two angles up. That'd be 120 degrees. And then do 180 minus the 120. And then, what does that get us? 60 degrees. And then you go back and you do 180 minus 60 degrees. And then you get back to 120 degrees, which is what we said it would be in the first place. And this triangle, all the angles are acute again. So you could say it's a scalene acute triangle. And that'll be it there on that one. Okay, next few here are going to use the idea that your two remote interior angles equal your exterior angle. So what I would probably do maybe near this section here, is this something you're going to want to study here? Just draw yourself a triangle. Let's extend one of the sides. And then I'm going to label this here with angle A, angle B, and then I'll put an angle 1 right here. And the way the formula works is we're going to say the measure of A plus a measure of angle B, and then equal the measure of angle 1 right there. So it's the two inside angles right here equal this one exterior angle, because you're going to need to be able to do that on some of the problems with the algebraic expressions. Otherwise, we'd have to write an expression for this angle and use a linear pair, and it's kind of harder to do when you got the 3x minus 22. So what I'm going to do is I'm going to say the x plus 80, those are my A and B angles right there, and that's going to equal the 3x minus 22. Okay, and then you can subtract x and get 2x. You can add the 22, that'll give us, I think, 102. And then we can divide, and that'll be 51 right there. And that'd be your value for x. So once again, it was these two angles combined right here, and then equals this angle right here, 3x minus 22. Okay, let's go ahead and try a few more here. Same thing, some slightly different numbers here. Here's these two angles, and then your one exterior angles right here. So you could go 2x plus 3 plus a 51, and then equals 4x plus 8. Okay, and then you can combine up your like terms there. That's 2x plus 54, and equals 4x plus 8. Could subtract 8. That's going to get us, what's that, 46. I guess we could subtract the 2x at the same time if you wanted. That would happen to get us 2x over here, and then when you divide, that gets you 23. So that's that there on those. 6, same thing, slightly different numbers there. We can go 2x plus a 103 minus x. Those are your two interior angles, and then equals that one exterior, 6x minus 7. We got just x plus 103 equals 6x minus 7. I'm going to subtract x, that would give me 5x. I'm going to go ahead and add 7 at the same time, that'll be 110. And I think 5 goes into that 20 something, what is that, 22 maybe? 10. Yeah, that should be 22. And that'll be it there on those. Alright, next, number 7 here. Probably the biggest thing people are going to mess up here is the fact that these kind of look like they're alternate interior angles. They didn't really tell us that the lines are parallel, so we're not going to say that they're congruent. I mean, obviously they're different numbers, so hopefully you don't run into that, but let's use the fact that we got a linear pair going on right here, so that should all add up to 180 degrees. So let's go 180 minus the 58. I think that's going to be 122 for angle 2. I guess I'll just write it in right here. It's kind of small. I guess let's squeeze that in there. 122, and then use the fact that all three of these here need to add up to 180. So 122 plus 22 is 144, and then let's do 180 minus 144. And that should be, I think, 36 degrees if I'm doing my arithmetic correctly. So angle 1 is 36, and then now we can go do the same exact thing over here on the other side here. 122 is vertical from angle 3, so we can actually put that right there. Then now I'm going to go 122, and then this time plus 20. It's me 142 this time. 180 minus 142 is 38. And then I guess, yeah, that's it. 38 degrees. So let's see, 3 was 122, and 4 was 38 degrees. Alright, so perfect there on that. Okay, now from here and down, we're going to have to determine if these triangles are isosceles or equilateral, because they're going to be kind of talking about some of the sides and everything here. So let's look at what's going on here on this one. So this one here, I notice all sides are the same, which means there's a property we learned: if you have an equilateral triangle, it's also equiangular, which means all angles are the same. So what I'm going to do here is I'm going to do the 180 degrees, and since all angles are the same, I'm going to divide by 3, and that's going to give me 60 degrees. So that means this angle here is 60, this angle here is 60, and then this angle here is 60. And then you can just go 5x equals 60 degrees, and then you can divide and get your value for x right there. Another way you could do it is, since it's also equiangular, you could also go ahead and write in a 5x for each of these, and then say 5x plus 5x plus 5x equals 180. But when you divide, you should still get 12 there at the end. So it's a couple different ways to think about that. And that's because it's equilateral, which also implies equiangular. So keep that in mind right there. So all of these should be 60 degrees, and that's only specifically with equilateral and equiangular triangles. 9 is actually going to be an equiangular triangle. I know this because I got two 60s, and so that kind of looks like it should be isosceles. Some people say, okay, well then these opposite sides here should be the same, but the issue is they don't tell you what that side on the left-hand side is. So what I'm going to do here on this one is say 60 plus 60 is 120, and then when I do 180 minus 120, it gets you 60 degrees, which then therefore, it shows us that it's equiangular. And then if it's equiangular, it's also equilateral. And if it's equilateral, then I can go and take this 2x minus 3 side and then equal to 7. And that's going to be your approach on that one. A little bit advanced on that one. But then after you divide, that's x is 5. Okay, now number 10, this one coming up here, this one's actually truly an isosceles triangle. That's because the two angles are congruent. The sides across from the angles are going to wind up being your congruent sides right there. So I want y'all to go 15 and then equals 4x plus 3. We could subtract 3, we can get 12, and then you got 4x right there, and then we can divide and we get x equals 3. Alright, and that's because it's an isosceles triangle there. So that'll be it there on those.